Well, I think a part of it you might be able to see just from the tour that walking around this particular facility. QCT has been very active and growing greatly in the cloud space, addressing large Tier 1 CSP challenges as well as Tier 2 as well, and doing a good job of that. In doing so, they realized that they needed something where they could demonstrate solutions to their customers, real solutions, because as all of you who work for CSPs or other companies in the Silicon Valley and beyond, providing cloud services, you can't just take 10 nodes out of your data center and try something out. See if it's going to work. We can. We can identify with one of you and work with you and put a solution into the solution lab where you can connect remotely. And when we looked at what QCT was proposing to do in their solution center and what we have as well, we build up labs as well. But being able to take real equipment, document it into a reference architecture that you can take into your facility, understand the switches and settings that we put together and how it all works together. So Quanta and Intel made a natural good choice for this particular engagement and their Solution Center Lab, which I am going to promote. Please make sure you take that tour. So today, these slides I'll sort of hit through them because I made a commitment to you that you guys are going to be first in line at lunch, right? So I know what I'm going to tell you, and I just told you what I'm going to tell you. Now I'm going to tell it to you. We worked with a large Tier 2 CSP. We identified the challenge. The challenge is, as typical, they wanted to grow quickly, but they wanted to grow in a cost-effective manner because their software as a service that they offered was essentially their cash register. And they couldn't scale without taking cost into consideration. Their previous solution that they were implementing and trying to scale was an iSCSI solution. Now, performance was very good, but when you look at the manageability or being able to manage that solution and scale at the scale that they needed in order to address their customers' SLAs or service level agreements, was just cost prohibitive. And the management was taking too much time, and it was taking too much time to scale that infrastructure. Ceph, which the OpenStack Ceph, which the block store implementation of Ceph, naturally fit the framework of being able to scale at the level they needed to do. You just map your RBDs to your OSDs, which I'll go through a diagram in just a bit. And so it offered, that framework was the seed for which we started. It offered a great framework. But as we know, there's cases and lots of cases where Ceph performance can be good enough, but in this particular case, we were looking at a Hadoop workload, and we wanted to take storage, the storage locally that's typically used by the MapReduce function and stored in an HDFS file format, and we wanted to move that over the Ethernet so that we could create pools of storage rather than have these replicated Hadoop storage clusters throughout your infrastructure, IT infrastructure. And in essence, create economies of scale and save money from not having to provision, over 3 times the storage for each time you wanted to create a Hadoop cluster. We looked at that. So Ceph was the starting point and the seed. We knew that had the framework with which we could do something more. And when we took a look at it and we did some initial tests as we were building up here in the lab, we did it on a 3-node cluster, and the performance of Ceph was not really working the way we needed to in order to move it over Ethernet and still make it appear as if it was local. So what we also did is we took 2 aspects. We took a product from Intel in our Intel SSDs, and we took our software that is linked to those SSDs called Intel Cache Acceleration Software. And it is unique in the market because it doesn't prioritize the caching just on 2 parameters. It bases it off 32 parameters. So we had a little bit more leeway in which to structure and prioritize within the cache. That combined with our non-volatile memory express Intel SSDs, our P3700 SSDs, 2 terabytes, and we use that as caching mechanism between the Hadoop cluster and the Ceph storage node. In doing so, we ran several experiments, and what became of that was we were able to essentially make the storage in that Hadoop cluster and put it down in the Ceph storage node. Now you're thinking, okay, wait, hold on just a minute. I know Hadoop, right? Hadoop is MapReduce, and it has its HDFS. Where are you putting Ceph? Well, the key aspect of Hadoop that allowed us to do this is that it does come in two parts. It comes in the MapReduce function, the actual data analysis aspect of it, and it comes in the HDFS, with which we could shim Ceph into that infrastructure. What that allowed us to do, when we take a look at it, is it allowed us, I'm going to come back to this, it allowed us to be able to, one more, it allowed us to essentially be able to put an RDB from Ceph, if you're familiar with the Ceph block infrastructure, put it in here and map it to OSDs in multiple Ceph nodes. So we had 7 Hadoop clusters and we had 7 Ceph storage nodes. Whenever we were able to do this and tailor that with Intel NVMe SSD drives as our write journals and our caching, and we split it between the two, so we had 24 hard drives in this particular storage node. What we did is we had one control hard drive 1 through 12, and we had the other NVMe control 13 through 24. So essentially we took a solution and we were able to create this storage and make it look just like a Hadoop node that thinks the storage is locally. Why is that important? I'm actually going to poll the audience on this just real quick. Why is that important? Why is it important that we could now extrapolate this storage in the Hadoop node and put it over Ethernet? It's all right, I'm not going to. Well, the reason why is that initial claim for scalable, cost-effective scale. When we talk to customers, like specifically talk to FSI customers back in New York, one of their challenges is that they had 1,000 Hadoop nodes. What that means is someone went and took their central data store, took the data that they needed, whether it's customer data or banking data or financial, and they had to copy it into a Hadoop cluster. And when you copy it into a Hadoop cluster, typically your setting for replication on Hadoop is 3. So you've just made 3 copies of that data that you probably already have 3 copies of. Then someone else came and probably took an overlay of similar data and made another Hadoop cluster. Well, by the time you have 1,000 Hadoop clusters, how much replicated data do you have? How much excess? Yes, exactly. So that's one of the challenges. That's why we picked Hadoop, well, our customer, end customer, the large tier 2 CSP. We took that workload as the basis for which we would prove out being able to scale this solution and provide a framework for a greater TCO or return on investment for the mechanism with which to store. And so what you now have is you have this central data store that your Hadoop cluster doesn't need to come. They can access that central data, and it only needs to make 1 copy of the data locally if it needs that. And then so the replication factors that you set both in Ceph and Hadoop can be scaled down. You're pooling from a central data store that's over Ethernet, and you're able to make that data over Ethernet appear as if it's local. So you've got the performance that you need. So now, what you have is a solution that, as I mentioned earlier, is running in the lab today. We have demonstrated it, and we have performance numbers. And what we were able to do is we ran 2 key benchmarks for Hadoop. The TeraSort, so the amount of time it takes to sort 1 terabyte of data for a Hadoop node, and then TeraValidate, the amount of time it takes to validate that that data is actually sorted. And when we ran the benchmarks, this is the baseline without our caching software. So we still had the non-volatile memory, or NVMe Intel SSDs, our P3700s, 2 terabytes each of those, which helped us increase the performance of the Ceph nodes to the Hadoop node. But when we added our cache acceleration software, so taking in not only the software from Ceph, the Hadoop, and setting and optimizing those configurations, we overlaid our cache acceleration software, and we were able to achieve, up to 61% improvement in performance. And here, lower is better. So the blue bars, the lower is the better. That means less time it took. So now, what have I just told you? I've just told and explained a solution where workloads, from a general block store implementation perspective, you can now truly implement a disaggregated store solution, block store solution within your infrastructure. I'm going to pause here and open it up. Does anyone have any questions? Yes, sir.
So you said that this current customer previously was running iSCSI implementation?
They're running iSCSI, so you have to take the LUNs, you have to map it. It's the manageability.
Why did they go straight to an Apache with Ceph?
Well,
Well,
that's what they were using. They were using Apache. Oh, with Ceph storage?
Right.
So when looking at, they wanted to be able to scale much quicker, and the manageability aspect was one of the challenges, right? So managing this solution as it scaled was a big challenge. And so Ceph addressed that with the ability, you don't have to map the LUNs every time and mount the storage and all that. You can just map RBD to OSD, and that can be done remotely and very quickly. The second reason that they wanted to do the Ceph is we were able to determine that we actually could shim it underneath HDFS. So this is a very novel. I mean, you won't see this solution anywhere else. Yes, it's well, the customer that we worked with was, we'll have to credit them in their innovative thinking. They're like, could we do this? Does this make sense? And the challenge here was, the customer had this initial thought, but really, they couldn't take 7 nodes, 14 nodes, however many, out of their production system and be able to test this. We tested this from February to June. Their manager would probably be breathing down their neck, their director, their VP, put that equipment back in, because that equipment is essentially their cash register. So they would have to justify that, yes, this is going to return such, and how do you know without testing? And so this is where the partnership between QCT and Intel and leveraging the Solution Center was really key in being able to demonstrate a real-world solution. And as I'm, they're in the process of cutting over. Yes. Yes, sir. We went with Intel Ethernet. So we did, on the private side, we did 10 gig to the between the Hadoop node and the Ceph node. And on the private, because of the replication aspect, we did 40 gig. We did not use iWarp. Any other questions? Pardon me? No, we did not use Rocky as a ROC. I'll have to check. I think they did at the top of rack switch, but I don't know specifically. Where is? I'll remember that. I'll check up on that. If you give me your business card, I'll get back to you, sir. Any other questions? Isn't this awesome and exciting? To me, this is awesome and exciting because we did something that hadn't been done before, and we solved it in a way that's just no one had thought about it before. We're shimming another file system under a file system, and we're making it better. And how we're doing it was, again, software is key. The key element here is that, working with a partner like QCT, they realized, how key the software is. They know they do a world-class job on the hardware. And they really brought the resources to bear and leveraged and hired, as they needed, true software expertise in order to be able to do this. Because there's a lot of, if anyone's familiar with Ceph, there's a lot of variables and switches that you need to set, as well as Hadoop. And so what do you do? We tried different aspects. What if you do Hadoop replication 1 and Ceph replication 3 or Ceph replication 2? We tried all kinds. What is your queue depth that you need to set and things like that. And so we got to play around with it. And the key aspect here is, being able to work with a partner and be able to go out and identify key challenges that are in the industry today and be able to solve it with equipment that is available today and demonstrate it right as soon as you get out of here. Well, after you have your lunch, because I did promise that. And I think there is a tour, either in conjunction with lunch or just after lunch. So that essentially is what I wanted to discuss with you today and what I wanted to tell you. So I told you what I was going to tell you. I told it to you. And then I told you what I told you just now, what I just told you. Yes, sir. With professional, so that would be over, you would want to talk to QCT. It's a QCT solution. We're working in partnership with them. The reference art, we've done a white paper that's published on this. In fact, I should, for those of you that want to take, here's a picture of the actual rack that is in a conference room just across the way. So this is the rack that's there, that's running right now, running this equipment. And then we have a white paper that we did in conjunction with QCT. We're also in the midst of documenting all of the details in a reference architecture, which soon will be released. And we've demonstrated this at a couple of events, our IDF, VMworld, and such. And we're going to be demonstrating it. If any of you are going to OpenStack Barcelona, we'll be demonstrating it there as well. So with that, I'm making true to my promise. And we're done. If there's no more questions, thank you for coming. Really appreciate your participation. Awesome.